So just a quick show of hands, how many people have used SQL before, have used a database of any type? Oh, okay. No, that's good. So we're going to start right from the beginning with a look at what databases are. I wanted to make sure this is just all-inclusive, soup to nuts overview of Postgres and PostGIS. So starting with databases, what are they? For the purposes of this talk, a database is just a collection of tables of data, and it needs to provide a system for manipulating and retrieving that data. So we're talking about relational databases. Postgres is a relational database. Usually when you hear the word database, that's what people are talking about. But there are other types that we're not going to get into, but I felt like it was important just to mention. So let's start with a super simple example of what could be a database, although it's just an Excel chart here. So imagine we have a database with a table called hospital and a table called department. And we have just general information about our hospitals. We've got names, telephones, how many beds they have, where they are, but just a text version of where they are, the address. And then we might have a table that keeps track of their departments. So we've got different kinds of departments. We've got primary care, gastroenterology. And you can see here in the department, maybe you can't see from the back, I apologize. But in the department table, we've got an ID called the hospital ID. And that is, it's meant to point back to the hospital table. So the relational part of relational databases is the relations between those tables. And the idea, we're not going to get too much into like what's a good database design, but the idea is you don't want to put everything in one table. You want to try and split it out, just as logically as possible. So, Lady of the Lake, for example, has primary care. It's got neurology. It's got gastroenterology. And you can see that by looking at the department table. So the way we retrieve data from databases is via SQL. So let's look at two really quick, simple queries here. The first one, we're just pulling everything from the hospital table where the beds are over 1,000. So hopefully pretty human readable. SQL was designed with that in mind. It doesn't always live up to that, as we'll see shortly. But at least for the simple stuff, it's hopefully pretty straightforward. So that's the first query there. And then the second query kind of gives an example of a join, which is what I was sort of alluding to in the previous slide, where we have data in departments that we want to look at in hospitals. We want to look at a joined view of that data. So we're selecting a specific field from the department. It's called the department name. So we take our hospitals table here. I'm just going to go ahead and point. Got hospitals here in the from clause. And then we've got an inner join. We'll sort of organically approach different types of joins in the talk, but basically we've got departments and hospitals, and we want to join them when the hospital ID equals the department ID. And then we also want to filter where the hospital's name is Lady of the Lake. So this is just a quick overview. We're going to get more into this in the lab. But basically just be aware that this ability exists. So that works great for basic data about hospitals. We got beds, departments. You can imagine that could be a huge nationwide database of hospitals. So where does the GIS stuff come in? So we know basic capabilities of hospitals, but what if we want to answer questions like how many hospitals do I have in my county, or how many residents are around it? Say something goes horribly wrong, disaster strikes. How many hospitals do I have in 100 miles of where I am? So we start to, these limitations are painful with our previous design. So what can we do about that? We have an address, so we can try and parse that out, but that's kind of ugly, right? We could find the latitude and longitude, but how do you represent that? We could have a column for latitude and longitude, but that might not work with off-the-shelf software and stuff, and we have to write custom software. And then what happens, it might work for hospitals, but what happens if we have a more complicated geospatial, like a county? How do we represent like a polygon or a line or a road with our simple lat-long scheme? So that's where Postgis comes in. So this is pretty much just stole this from their Wikipedia. So go to Wikipedia for more information. but Postgres supports points, lines, and polygons in their multivariants. So imagine a bunch of points or a bunch of lines, or a bunch of polygons. It provides geospatial operations such as distance, area, length. We're going to get into all these in a little bit. But just imagine we've got 2 polygons and I want to know how much they overlap or how far apart they are. It provides all of that out of the box. It provides the ability to index these geospatial objects. We're not really going to get into how indices work or really even how to use them, but just be aware that exists. And if you have a lot of geospatial data, having an index on it is going to make retrieving that data a lot faster. And then it is natively supported by a lot of tools. So I can go point to a Postgis database in QGIS and just be able to pull the tables that I want. I can point to it in GeoServer. I can probably point to it with a lot of stuff. But our sort of custom lat long column solution, it wouldn't be standards-based. It wouldn't be supported by stuff off the shelf. More stuff stolen from Wikipedia. So this is just sort of an illustration of what I was talking about: points, line strings, polygons. Polygons can have holes. It's important. And then they're variants rather. Postgis can support other data types. This is just a subset. Triangulated irregular networks. Some other stuff that I've never used. This is the stuff I use like every day. So that's all we'll be focusing on. But it supports more than that. Don't want to sell it short. So what does it look like when we put this geometry object in our data? So if you go into a table with the geom column, as it's usually called, you'll see something like this. This is out of our lab database. We've got the name of the country it looks like, and the admin. Oh, this might be like a city or a county or something. I forget where I got this. But basically, we got some non-geospatial data in column 1 and 2. And then we've got the geom, and it's some inscrutable numbers. This is what's known as well-known binary. It's not really meant to be looked at like this. You want to go put it on a map, but that's just what it'll look like. So if you guys are browsing tables and you wonder what that big ugly thing is, that's what it is. It's a representation of the geometry in this well-known binary format. So I'm not even going to read through all of this. I've got the slides available online, but basically I've got 3 walls of text that sort of provide a summary of what Postgis offers from a function standpoint. What can it do? I mean, it can represent my data, but how can I interact with my data with these functions? So the ability to measure distances, as I mentioned before, the ability to get the centroid of, let's say I have a bunch of points. It can give me the middle point of that group of points. It can tell me if 2 geometries are touching or not touching, or if one contains the other, all sorts of stuff like that. So let's take a quick look at this. And we're going to kind of learn more SQL as we go. So for people who aren't super familiar with SQL, we looked at select statements before. Select statements can contain select statements. So basically, let's look at this from the inside out. We've got 2 things we're retrieving here. We want to get the geom column from a table called cities. And we want to just get the record where the name is Seattle. So this returns the point that represents Seattle, where Seattle is. And then for the second argument, we got the same deal, but we're getting New Orleans. So we've got 2 geoms here, and we're passing them to the distance function. And this third argument is whether or not we want to get forget the name now. Basically, do we want the answer in miles or kilometers, or do we want it in the sort of Cartesian answer, like, well, imagine it's a big flat 2D plane. So we want the answer in kilometers, and we're actually converting it to miles. And this gives us the distance in miles. And I looked it up on Google, and it turns out I was right. So our second wall of text, so we just looked at a bunch of functions that tell us facts about geometries, length, area, stuff like that. We've got this set of functions that allow us to transform geometry. So I'm sure you guys are all map people. You've felt the pain of working with projections and stuff. So Postgis supports that out of the box. It's got functions to take a polygon from one coordinate set and convert it to another. It allows you to set the coordinate set, the SRID, and just functions to get the envelope of something. So if I have a complicated polygon, I just want to get the bounding box around it, I can do that. I can rotate stuff. I can get affine transformations. I don't really use that a whole lot, but they exist. So 2 more examples. So the first example here, we're pulling that point from the cities table, and we want to just tell us the SRID. It's 4326. And then we've got the second query here, transforming it. So we're pulling that same point and then using the st_transform function to convert it to Web Mercator. And then we want to look at it as text. We'll look at it as text in a second. But this is basically the well-known text representation of that polygon. And I'm sorry, that geometry, which is a point. And now we can see it's been transformed into Web Mercator, which is the number of meters from the prime meridian, right? I think that's right. So finally, we'll just look at some a final set of functions that it provides. The ability to get a geometry object from well-known text. We just saw some well-known text before. You can get it from KML. You can pull it in as JSON. I don't use that much, but those exist as well. I don't have an example of how you might use that, because the best way to get stuff into Postgres, in my opinion, Postgis, is the utilities shape to PGSQL and raster to PGSQL. So I'm sure you guys have worked with shapefiles before. You basically take a shapefile, use this utility, Google for the specifications. I didn't want to get too deep into it, but I just wanted to make sure everybody knew that you didn't have to sit there typing, point, blah, blah, blah. It's super easy. Just put your whole shapefile into the database and go from there. So we're going to have two kind of more advanced examples here, just to sort of show the power of Postgis. And they're sort of whimsical and silly. The first one, or third one according to the slide, which two cities on Earth are farthest from each other? So I've got a map here. This is the database, the lab database in QGIS. And I found, I don't know, a shapefile online or something that had all the major cities in the world. And I want to know which two are the furthest apart. So this is an example of a query that solves that. This is in pgadmin, which we'll be using in a little bit. So let's just step through it real quick. It's a little bit more complicated. These are actually a lot easier to write than they are to read, so I understand it's kind of, I don't know, it's intimidating looking. So all we're doing here is we're getting the city's name. This is the concatenation operator in Postgis. So basically what we're doing is name, comma, country name. So you can see, Santiago, Chile, stuff like that. So this is what we're selecting. We're getting the name from city one. I'm sorry, we'll get to that in a second. So a first name, a second name, and then the distance they are apart. So we've got, let's step back a second and look at the from. So we're pulling all of our rows from the city table, and we're doing something called a cross join, which joins every row from every other row in another table, or the same table, which is what we're doing here. So we're joining cities with cities. So you can kind of imagine our cities table. We've got 10,000 entries or whatever. And for every one of those entries, I want to compare it with every other entry in the same table. So you can see why we do that. We want to get the distance of those two things we're comparing. So this is just a little line here to, the table had a scale rank, and we want to make sure it's of a certain size, otherwise the query would take too long to run. So we only care about big cities, I guess, in this query here. And then order by. So order by is a clause in a select query that orders your results. So we want to know the furthest apart. So we're ordering by the output of the distance function. So we've got our first city, our second city. Once again, we want it in kilometers. Yes?
So when you do that, will it calculate the distance one time or two times?
2 times. So
well, I mean, like, though, because you're actually calling the distance function twice.
That's a really good question. So databases are really good at optimizing queries. So it's really hard to say without using Postgis has this explain. You can basically put the word explain in front of any query, and it'll tell you the query plan. So if you were familiar with reading the output of that, you could tell. I can't say for sure though. It might, but. My experience is databases are really good at optimizing stuff. I usually optimize my queries after I've found they're not running fast enough. So, but right. So we're ordering in descending order our furthest apart cities first, and then we also just want to show. I want to show that distance. So here's the results. I can't pronounce that city name. Zion and Santiago. Yeah. So those are the first. Actually, I looked this up, and. How big is the world? Isn't it like 12,400 something? This is about as far apart as two cities can actually be. So kind of interesting. And then I cut off the results here. I actually have this query in I forgot these lights turn off.
I mean, it's kind of okay like this.
Yeah, maybe it's easier to see. Then I'll stand very still. So, so I've got this query. I'm gonna have a link to download the project files. So if you guys want to run this or play around with it, I've got that online. And then finally, one more silly example. So my family's pretty spread out. I live in Seattle. My sister's in Virginia, and my parents are in New Orleans. So meeting up for Christmas is inefficient. What is the fairest place for us to meet for Christmas? So this was a little bit more complicated, and we'll kind of skim over it. I realize this is sort of diving in deep. This is really just to show off like what Postgis can do. So we're doing a couple of things we haven't seen before. So I mentioned selects can contain other selects. You can name those selects with the with clause. So what we're doing here is basically we're defining sort of like a temporary table. Just I want to select the name, the geometry, and that's it, from the cities table. Just give me New Orleans, give me Blacksburg, and give me Seattle. And then just call that fam city. So now from here on out, we can just pretend there's a table that exists called fam city. So from that table, we're going to kind of work our way out from this. So from that fam city table, union those together. So st union takes a bunch of points and it returns a multi-point. With that multi-point, so remember we're going inside out, use the centroid function to which takes multivariate, so multi-points, probably takes multi-lines. I'm not sure exactly what it takes, but I know it takes multi-points. And it will give us the geometry that's in the middle of those points. And then finally, tell me the distance of that value from all of the cities I'm looking at in the cities table. So we're just doing select all this stuff from cities, and then order. We're once again ordering by this big complicated operation. Give me the city that is closest. This time we're not ordering descending order. Anyway, big complicated thing. The answer is Hutchinson, Kansas. And actually, that's not even the answer, because unfortunately, centroid does not use is a geodictic. It doesn't use the curve of the Earth. Yeah, unfortunately, it. And I found it out after I wrote this, so I wasn't gonna let this funny example go to waste. But it's mostly useful for points that are close together. So this is not a very accurate answer, but it's more fair than flying to New Orleans, which is what we currently do. So that's it. That's all I'm gonna say. Now it's time to start the lab. So we've got the lab instructions at that link there. I've got the project files on my GitHub, and I'm going to leave the lab database up after this. So just do as much as you can. If you guys just want to mess around with it, I mean, the lab questions, they're just examples. Just do whatever you want. And I can be reached at that email address if anybody has any questions after tonight. And I'll just be walking around helping people out. Yes?
Question about the cross join. Do you know why? Is it because if you just put the two tables without any join statement, you also get cross join? Do you know why it would be preferable to use the cross join keyword?
It's sort of just syntactic sugar for me. Yeah, you're right. If you
I really want to do this.
Right, exactly. I actually don't like. Some people like to do the from table 1, comma table 2, and then they'll limit it with the where clause. But I don't like that because then when you have the inner join with the specific join condition, it's very clear that's what it's for, because you've got all kinds of things that might show up in the where clause. So it's just personal preference for me. I never do the from table 1, comma table 2. I see what you're saying. I guess that would be a cross join.
And then is that with statement? Is that a Postgres specific thing, or is that?
Actually, I've heard that's part of the standard, but I don't know if everybody supports it. So it's definitely supported in Postgres, and I use it all the time. So that was one of the I got that out of a Heroku talk about 10 things you didn't know about Postgres that you'll love. I'm like, oh, I do love that.